Hey guys, and welcome back. Today we're going to be talking about how we can approximate the square roots of non-perfect squares. Remember, our test is going to be no calculator, so we need to know how to approximate to the nearest tenth and hundredth without using the square root button. So our learning target today is going to determine rational approximations for roots to compare numbers. Keyword here, it's going to be an approximation, and our approximation is going to be in rational form. So we're going to look to approximate a terminating decimal for a number that actually does not terminate. To be successful at this, we're going to identify the perfect squares. Okay, so we need to make sure we are memorizing our list of perfect squares. And we're going to use consecutive perfect squares to make an estimate for the square root. Consecutive meaning back to back. And then lastly, we're going to perform long multiplication to make sure that our estimations are accurate. So let's take a look at the first example. It says you're designing a booth for a comic convention. The booth is 7 feet wide and 6 feet deep. You plan to place a square rug, okay, keyword square there, in the booth, parallel to the walls. Each side of the rug is root 33 feet long. Will the rug fit? Okay, so if you are given a number, root 33, and we need to approximate about how long that is without using the square root button on our calculator, first I want you to think just about the number 33. Think about our list of perfect squares. So I'm going to think about the number 33. Off to the side, I'm going to write my list of perfect squares again. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and then 10 squared is 100. Okay, so what I want you guys to do is I want you to think of what two consecutive perfect squares 33 is between. When I say the word between, I want you to write two less than symbols on each side of 33. This is signifying that 33 is between something. I don't want you to write symbols facing the other way, like this. That's no. And I don't want you to write symbols facing the opposite direction, okay, like that or like this. Okay, we should not be writing the inequality symbols like that. None of those represent between. Only when you have them pointing left does it represent that 33 is between something. So let's look at our list of perfect squares. What two numbers is 33 between? Now you can say that 33 is between 4 and 64. It definitely is between 4 and 64, but I want you to pick two numbers that are back to back. Where 33 is sitting between. So if I look at my perfect squares list, it looks like the two numbers that 33 sits between is 25 and 36 back to back. So I'm going to write that 33 is between 25 and 36. The lower number should be on the left. So now, if I want to compare that to what the square root of 33 is, that means I have to square root 25 and 36. So square root everything you see. Now, I don't know what the square root of 33 is, so just drop that down. And now I know what the square root of 25 is. That's 5. Square root of 36 is 6. So now I know that the square root of 33 has to be between 5 and 6. So it's going to be 5 point something. Okay, well, I need to figure out what that something is. And in the directions, it does say, let's see, it doesn't say any rounding directions. So I would say rounding to the nearest tenth would be a good idea here. So I want to basically just start guessing at what that decimal point could be. A way you can try to take a better guess is think about how far away 33 is from 25, and think about how far away 30 is from 36. Now, from 25, 33 is 8 units away. From 36, it's only 3 units away. So in the center of 5 and 6 is 5.5. maybe we want to guess a number a little bit bigger than that because 33 is closer to 36. So the square root of 33 will be closer to 6 than it is to 5. So I'm going to guess 5.7. Okay, what is 5.7 squared? Well, that's 5.7 times 5.7. So I'm going to do my long multiplication. 7 times 7 is 49. 7 times 5 is 35, plus another 4 is 39. Drop down a 0. 5 times 7 is 35. 5 times 5 is 25, plus another 3 is 28. So now I've got 0 plus 9. 9 plus 5 is 14. Carry the 1. I got 12 over there. Carry that 1. And then I see 2 decimals, 2 numbers to the right of the decimal. So I should put 2 numbers to the right of the decimal on the bottom. So I've got 32.49. So we're still a little bit below 33. Okay. So I'm going to try one more, and that is 5.8 squared, which is 5.8 times 5.8. Now my hope is that with this guess, it'll go over, and then I'm going to pick whichever one is closest to 33. 8 times 8 is 64. 8 times 5 is 40, plus another 6 is 46. Drop a 0. 5 times 8 is 40. 5 times 5 is 25, plus another 4 is 29. So I've got 0 plus 4 is 4, 6 plus 0 is 6, 4 plus 9 is 13, carry the 1. Okay, so now I know that the square root of 33 has to be somewhere between 5.7 and 5.8. Okay, well, which one would be the better approximation? Whichever is the better approximation is whichever number down here is closer to 33. Well, 33 minus 32.49, that's equal to 0.51. 33.64 minus 33 is equal to 0.64. So since 0.51 is smaller than 0.64, then that means this number is closer to 33 than the other. So my approximation for the square root of 33 to the 10th would be 5.7. So I'm going to write that off to the side here, that the square root of 33 is approximately, whenever you make a wavy equal sign, that means approximately 5.7. Okay, now to properly answer this question, it says each side of the rug is root 33 feet long. Will the rug fit? It says the booth is 7 foot by 6 foot. So this rug will definitely fit because each side is only 5.7 feet long. Let's have you give this a try in your first U-try. It says on a number line, between which 2 consecutive whole numbers would root 70 be located? So just be aware, you guys don't, in your U-try, you guys don't even need to go this far. Okay, you don't even need to estimate this. Not necessary. All I want you to do is stop here when you find the 2 integers that the square root is between. So what 2 whole numbers is the square root of 70 located? Give it a try. All right, I've got another U-try for you. It says the square root of an integer n is between 9 and 10. What are all the possible values of n? Okay, so I want you to think there is some square root of a number we don't know. Follow the process where you would place that between, the square root of n would be between 9 and 10. So what would be the opposite of squaring in order to find out what n would be between? Try to give this a shot. See if you can get this one on your own. All right, so I've got one more example here. It says your friend points out there will be a gap between the rug and the walls of the booth. To calculate the size of this gap, you need a better approximation for the length of the rug. So we already did the square root 33 to the nearest tenth. We had that at 5.7. And we can make a number line for this as well. I'll actually put this on the number line after we do the hundredth spot. But let's try to estimate where the square root of 33 would be to the nearest hundredth. So we know that the square root of 33 is between 5.7 and 5.8. That's what we discovered on our first example. We said 5.7 was just the better approximation. Well, now we're going to get it down to the hundredth, and we're going to decide between two of them which is the better approximation based on how far away they are from 33. So let's try the first number to be halfway between the two, which would be 5.75. That's halfway between 5.7 and 5.8. So I need to do the long multiplication like we did on the first example to see what 5.75 squared is. Okay, so I'm just going to do the long multiplication real quick here. Don't forget to drop those zeros. Okay, so I'm getting 33.0625 for 5.75 squared. So since that's over 33, I'm going to try now 5.74 squared. So 5.74 times 5.74. I'm going to do that long multiplication, and we'll see which one's closest. Okay, there we go. All right, so I'm between 33.0625 and 32.947. So I need to know which one of those numbers is closest to 33 to figure out if I want to choose 5.74 or 5.75. Okay, so I'm just going to do some subtraction here. Just the bigger number minus the smaller because we just want to find distance. So 33.0625 minus 33, which would really be 33.000, is just 0.0625. Then 33, I'm going to give myself some zeros so I can do the proper subtraction. Minus 32.9476. We're going to have to do some borrowing here. Okay, so let's see. I need to make this 0 a 10, which means I have to take from this 0, this 0, this 0, and this 3. Well, if I take from this 3, it becomes a 2, which would make this a 10. But then this 0 had to borrow from that 10, which makes it a 9, making this 0 a 10. But this 0 had to borrow from this 10, which would make it a 9, and this a 10. And then this 0 has to borrow from this 10, making it a 9. And finally, that's where our 10 would come from. So it's really 2.999 with a 10 at the end. So 10 minus 6 is 4. 9 minus 7 is 2. 9 minus 4 is 5. 9 minus 9 is 0. And then 32 minus 32 is just 0. So I'm comparing 0.625 to 0.524. Well, this one is the shorter distance. So that means that 5.74 is closer to, or 5.7 squared is closer to 33 than 5.75. So our approximation to the 100th should be 5.74. If we're going to draw this on a number line, the way I would do that is I would maybe go by tenths. So let's say this is 5.2, 5.3. You know what? I could probably start that off a little higher. Let's do 5.5, 5.6, 5.7, and 5.8. So I would, on a number line, show that it's a little bit less than halfway between 5.7 and 5.8, and then I would label that as its original number, which is the square root of 33. So you guys can actually see visually that the square root of 33 is between 5.7 and 5.8, just a little bit less than halfway. So we did a lot in example 2. We approximated to the 10th in the first example, and then we went a step further, approximated it to the 100th, and we also placed it on a number line. What I want you to do on your U-Try, you don't have to do that much. Okay, that was a lot of depth. All I want you to do is to approximate the square root of 50 to the nearest 10th. You don't even have to go all the way to the 100th. All right, I got one more last close and check question for you. I will be grading how you respond on this. If you need to, make a list of perfect squares and try to go beyond 12. Okay, so as you can see, you have 136 being square rooted, so you might have to generate some more perfect squares by doing 11 times 11, 12 times 12, 13 times 13, so that you can see what two perfect squares 136 is between. Go ahead and give this a try. All right, that just about wraps up our learning target today, determining rational approximations to roots to compare numbers. We approximated them to tenths and hundredths. We had to identify perfect squares to do this. We had to identify what consecutive perfect squares were and use that to estimate what the square root was between. And we also performed that long multiplication. Okay, we did the identification of perfect squares in all three examples. We identified consecutive perfect squares in all three examples, and we performed long multiplication in all three. So if you have any questions on what we reviewed today, what we went over, please let me know. Go back and rewatch any sections you may not have understood, and now you may start your Google form. Have a great day.